Alrighty. So, we're going to continue our study. Or actually, I guess we can kind of think of it this way, right? So, what we've kind of been doing, right, is learning how to solve kind of relationships with quadratics and then polynomials, right? And like we use like solving equations with quadratics and polynomials, solving inequalities with quadratics and polynomials, and then we're going to actually go back to the idea of like factoring and how do we factor and what kind of tools can we use to do that, right? We've already developed some tools when it comes to factoring. We can use like GCF. Right? We can use, the quadratic. We can factor quadratics pretty easily too. We can also use grouping. We can also use the substitution. Like the thing where we take a polynomial, make it look like a quadratic, and factor it that way. All right. But there are still some more tools available, right? Because there are still some polynomials that wouldn't work with, or wouldn't kind of like work. None of those strategies will work, right? So we're going to develop a few more tools that will help us, more kind of like general tools, all right, that we'll be able to use to help us factor things and stuff, all right? And so let's take a look at those now. Like I said, those involve long division and synthetic division. Okay. Now, before we jump into long division with polynomials, let's refresh our memories a little bit about like what even is long division, right, and how we do it, right? So let's take a normal long division problem, something like this. Let's say that I gave you 1,793 and I ask you to divide that by 4. Okay. So typically, right, people can't do this mentally, and so we'll instead kind of do it the long way. So we'll take our 4, right, which we're using to divide 1,793. Just like that. Okay. So the thing that we are dividing by is on the outside. The thing that we are dividing, 1,793, that goes inside the little symbol there. All right. Right? And so the kind of the procedure that we go through for long division, right, is to kind of like ask ourselves, all right, we think about what number times 4 will give us 1. And the answer there, right, well, there isn't a nice number that multiplies by 4 to give us 1. So then we kind of move over and we include the 7 with it, and now we think 17. We think 17. So we're like, okay, what number times 4 will get us 17? Well, we don't get exactly 17, but we can get close to 17 if we use what number? 4, right? 4, so 16, right? But then, so which we get by doing 4 times 4, and so then we'll put a 16 here, and we'll subtract it, right? Just like you can think of multiplication as repeated addition, right? 3 plus 3 plus 3 is 3 times 3 plus 3 plus 3 is 3 times 3, 9, right? 3 plus 3 plus 3 is 9. 3 times 3 is also 9. Repeated addition. Well, long division is repeated subtraction. So we're just going to be subtracting stuff off until hopefully we get to, our something that works out nice. Anyway, 17 minus 16 is 1. And then again we ask, can we, divide that 1 by a 4 again? No, so we know we chose well here. And so we'll bring down the 9. All right, and then we'll ask ourselves the question again, what times 4 gets us 19, or gets us close to 19? And the answer there would be 4 again, right? We could use a 5, but 5 would be overshooting, right? It'd be a 20, and we end up with a negative, and we don't want to do that. So 4 times 4 is 16, minus that. And again, we get 3 now, and 33. And then again, what times 4 will get us something close to 33 there? 8. Right? Okay, so 8 times 4 is 32. Subtract, and you get a 1 left over. And now we're out of numbers to bring down, okay? And it's at this point where we could continue if we wanted to. So for example, if we wanted to get like decimals, we could put a decimal point right here, put a 0, and drop it down, make 10, and then keep doing our division, adding more zeros as necessary until hopefully we stop or see a pattern, like a repetition. For our purposes, though, okay, we're going to stop at just this 1, okay, and say that means that's our remainder, right? Remainder 1. Maybe you see it written like this, okay? But of course, we also know that with our remainder, we can say, okay, that means there's 1 that we have not yet divided by 4. So it's 448 as our answer, and 1/4. Right? We haven't divided that last 1 by 4, and so we'll have to leave that just as a 1/4, which remember is the same thing as 448 plus 1/4. right? When you say 448 and 1/4, that really means 448 plus 1/4 like that. Okay? Or 448.25. Because if we did continue this, bringing down the zeros here, we would have, and you put the decimal point there too, you'd have 2, which minus 8 would bring a 2, and then another 0 would make 20, and now you put the 5 there, and you would see that it would subtract to make 448.25, or 448 remainder 1. And now it's kind of confusing that I have both the 0.25 and the remainder of 1 up there, but anyway, you see it, okay? So that's long division. All right, good times. I think I learned that back in 4th grade, I remember. All right, so let's take a look at long division using something a little more complicated. X cubed minus 19x squared plus 16x minus 4 all over x minus 2, right? Or in other words, dividing by x minus 2. Okay, so we want to do this division. So we'll do the same thing. We're dividing by x minus 2, so we'll put an x minus 2 in front, and then we'll put our little symbol there for the division, and then we'll write the 6x cubed minus 19x squared plus 16x minus 4, like so. All right, so then we need to figure out the same question that we asked ourselves before. What times x gets us 6x cubed? $6x squared, right. If we put a 6x squared here, that will multiply with the x to get 6x cubed. We want that lead term to go away. But then the 6x squared also needs to multiply with the negative 2, so we'll have minus 12x squared as well, because 6x squared times minus 2 is minus 12x squared. And we'll do the same thing we did before. We'll subtract this quantity. Okay. But I don't really like having that subtract like there in front of it. I like to distribute the minus sign. I like to distribute the negative. Okay, this subtracting here. So I'll make it plus, and then I'll just make everything in here the opposites, right? So make it a plus a negative 6x cubed and a positive 12x squared. Okay. And so then the 6x cubes cancel as they should. Right? Negative 19 plus positive 12, negative 7x squared, and then we'll bring down the 16x. Okay? Ask ourselves the next question. What times x gives us negative 7x squared? So again, what times x gives us negative 7x squared? Negative 7x, So we'll do a minus 7x there, times x, negative 7x squared. Negative 7x times negative 2, positive 14x. And again, we'll subtract the quantity. All right, but again, I'll distribute the minus sign there. So make it plus positive, and then a negative 14x there. Add them now. They cancel. 16 plus negative 14, 2x. Bring down that minus 4. Okay. It's super helpful here if you can keep things lined up, okay? Ideally, all of your x cubed terms should line up, all of your x squared terms should line up, all of your x terms should line up, and all of your numbers should line up, just like that, okay? So last step, well, not last step here, but the next step, okay, again, what times x gives us 2x? Right? 2, yeah, just so plus 2. 2 times x is 2x. 2 times minus 2 is minus 4. Subtract, and again, I'm going to change subtract to add the opposites there. Those cancel, remainder 0. Okay, so it divided evenly. That's nice. Okay. Thank you, Alexa. All right. So, what does this simplify to be? Well, if we do this division, we would expect to end up with 6x squared minus 7x plus 2. But I'm not going to just write this equals 6x squared minus 7x plus 2. I don't want to just do that just yet. Okay, you could, that's okay. But I want to do this. I'm going to put an x minus 2 in the numerator times 6x squared minus 7x plus 2. All over x minus 2 like this. Okay. Isn't that true? Isn't that true, right? We took this thing. If we divide out an x minus 2, we're left with the 6x squared minus 7x plus 2. So in other words, if I take my answer, the 6x squared minus 7x plus 2, and multiply by x plus minus 2, I better end up back at this polynomial, right? And I should, because that's how we got these two things in the first place. Okay. And now, yes?
Sorry, I have a question. Where would you put your remainder if you had one?
So we'll cover that. We'll cross it over just a little bit. But it's a good question. All right. We'll get there. I think on the next one, actually. So yeah. It's similar to what we did before, though. So anyway, what can we do here with me writing it this way? Now what can we do to help simplify? What can we do here to simplify this? Yeah, Park? Yeah, they can cancel, right? We can cancel these out. They both divide. They're the same thing, so we can then be left with just 6x squared minus 7x plus 2, which is what we had right here, right? Why did you do all this extra step, Mr. Whitmire? Okay, question, Ron? Oh, yeah, you want to go? Oh, you're just going to go? Okay, that's fine. Now, there's one thing I want to mention here that we kind of gloss over, but it can be kind of important here. We're saying that these two things are equal, right? We're saying all three of these things are equal here, okay? But what's the domain for this function? So, Ramike? Right, so we have to exclude 2. Why? Okay, but like, why? Why do we have to take 2 out? What does 2 do in this right here? Yeah, sure. We have to divide by 0, right? It'll be like undefined at 2, right? It's going to give an infinite value, right? Okay. What's the domain of this function? All real numbers. So, can we say that this function is equal to this function when they have different domains? Okay. So we can and we can't, right? Because oftentimes when we do problems like this, oftentimes we do problems like this, we say that they're equal and we just kind of move on, right? And typically that's okay because these things are essentially equal at all but one point, right? But to indicate that these things are still equal, what we do here is we typically throw in, or you'll see maybe in like more official math books or something like that, something like this. Where we say, these things are equal as long as x is not equal to 2, right? So that's why you'll see that little like comma thrown in there, x not equal to 2, okay? Do I expect you to write that in there whenever you do stuff like this? Not really, but I do expect you to realize and understand why it's there if you do see it, okay? And understand the importance of it, right? These things are not exactly equal. In math, the word equal means these two things are exactly the same. These two things are not exactly the same. These two things are exactly the same. These are exactly the same. They both have the domain restriction of 2, but then once we cancel those things out and say it's equal to this, now this and this, right? These are not equal except at x equals, or they're equal everywhere except at x equals 2. Okay, and that can matter. That can make a difference. Okay, because here I can plug in 2, no problem, get an answer. Here if I plug in 2, we get something that's infinite. All right. So anyway, it's important designation there. All right. Let's answer Madison's question then. So let's do another one. Let's do x to the 4th minus 10x squared minus 2x, I'm off the screen, sorry, thanks, plus 4. Okay. All over x minus 3. Okay. So, let's set up our division here. X minus 3 goes on the outside. I think I left myself enough space there. And then x to the 4th. We don't have an x cubed term here, all right? And this is something you want to be on your toes for this, all right? It's not necessary that you do what I'm about to do, but it is helpful, I find, just for organization's sake. Put a placeholder in. So how many x cubes do we have in this problem? 0. So I'm going to put plus 0x cubed, and then minus 10x squared, and minus 2x, and then plus 4, okay? So please make sure to include a placeholder. Okay, if you need to, right? There was no x cubed term, but we went from x to the fourth to x squared, so we probably should put a 0 x cubed in there just to help us out, okay? But then the rest of the procedure here is straightforward, all right? So what times x gives us x to the fourth? X cubed, all right? So we have x to the fourth, and then x cubed times minus 3 x cubed. Subtract that quantity, okay? And again, so subtracting quantity, we can add the opposites. So then the x to the fourths cancel. 0 plus 3 is 3x to the third. Bring down the minus 10x squared. And you can see why it was important here to have that 0. If you didn't put the placeholder in here, you'd be trying to add negative 10x squared with your 3x cubed, and they're not like terms, and it gets a little confusing, I think. All right, so it's helpful. All right, what times x gives you 3x cubed? Well, that's going to be 3x squared. So 3x squared times x is 3x to the third. 3x squared times minus 3 minus, 9x squared, my bad. Okay. So we're going to subtract that quantity. So then we'll, again, add the opposites. So plus negatives and positives there. 3x cubes cancel. Negative 10 plus 9, negative 1x squared. Bring down the minus 2x. And again, what times x gives us negative 1x squared? Well, a negative 1x. And then plus 3x. And subtract the quantity. And add the opposites. So those cancel. Negative 2 plus negative 3 is negative 5x. Bring down the 4. Okay. And then what times x gives you negative 5? Negative 5. These take up a lot of space, too, unfortunately. So make a plus positive and a negative there, so the negative 5 and the positive 5 cancel, and then 4 plus negative 15 leaves us with negative 11. It's also super important to be, meticulous here, because if you make an error early on, you're going to be carrying that mistake all the way through all this, okay? So, there's lots of opportunities for error, right? You're switching signs around, you're adding, subtracting things, just lots of calculations, and, very easy to get thrown off or something like that. Okay? So there's a remainder, right? Negative 11. How do we know it's a remainder? Because we don't have anything that we can really multiply x by to get a negative 11, right? I mean, technically you could come up with something, right? But there's nothing nice to multiply x by to make negative 11. So that's our remainder. So how do we account for this? Well, we're going to add negative 11 over the x minus 3. We weren't able to divide that negative 11 by x minus 3. It's remaining. It's what's left over to still divide. And so we just put it in there. Plus negative 11 over x minus 3. Okay? Just like that. If you wanted to, you could have put minus positive 11 over x minus 3. That would have been okay too. Okay. But there's our solution. Okay? So these, unfortunately, do not evenly divide. Okay? So, since this doesn't evenly divide, could we say that is x minus 3 a factor of this polynomial? Right? No, right? If they don't evenly divide, then we shouldn't then expect a factor does divide something evenly, right? So x minus 3 doesn't divide this evenly, so x minus 3 is not a factor, right? As you can see how we can use this long division to factor polynomials, right? We can check to see if things are factors or not. So x minus 3 is not a factor. Okay? X minus 3 is not a factor. All right. Madison, you're good on that, though?
Yeah.
Makes sense?
Yeah.
All right. Yep, you're welcome. All right, let's try another one here. Yes, we'll do one more here together. And then we'll move on to synthetic division. Okay. X to the fourth plus 3x cubed minus 10x squared plus 15x. So again, x to the fourth plus 3x cubed minus 10x squared plus 15x minus 10 divided by x squared plus 4x minus 6. So, believe it or not, right, we can divide by things other than just binomials here. We can also divide by, well, really any polynomial we want to. Okay, we can divide by any polynomial. Okay, the procedure is still the same. We're dividing by x squared plus 4x minus 6, and we're dividing the thing that's being divided, x to the 4th plus 3x cubed minus the 10x squared plus the 15x minus 10. Okay. No placeholders necessary here. We had all of our degrees from greatest to least there. So we ask ourselves the same question. Look at your lead coefficient here, x, or your lead term, x to the 4th, and your lead term here, x squared. By the way, if these are not in order from greatest to least, you need to put them in order from greatest to least, right? If these are like mixed around, go greatest to least, greatest to least. Okay. So here we have to multiply something by x squared to get x to the 4th, so that's going to be just x squared. So x squared times x squared, x to the 4th. X squared times 4x, 4x cubed. X squared times minus 6, minus 6x squared. Oh.
Oregon made double chocolate, and I made banana chocolate.
I get both?
Well, Mr. Goff and you can share.
Oh, okay, will do. Wow, thanks, guys. They smell delicious. They look so pretty. Okay. Very good. So, anywho, we'll subtract our quantities here. Okay, and so instead of subtracting again, we'll add the opposites. Okay, so those cancel. 3 plus negative 4 is negative 1x to the 3rd. Negative 10 plus 6, negative 4x squared. And then bring down the plus 15x. Okay. And then again, what times x squared gives us negative 1x cubed? Negative 1x. So negative 1x cubed minus 4x squared. And then plus 6x. And again, subtract the quantity. So subtracting the quantity, I will add the opposites. So negative 1 plus 1 cancels. Negative 4 plus 4 also cancels. 15 and negative 6 makes 9x. And we'll bring down the minus 10. And at this point, can we divide any further? Nope, we're done. So that's our remainder. So we'll say plus 9x minus 10 all over the x squared plus 4x minus 6. So sadly, that's the best we can do. Didn't divide either. Okay. So we can say, again, for this problem right here, we can say that this equals, and this one I'm going to skip the factoring and canceling stuff because it didn't quite factor and cancel perfectly. Are the domains for these going to be the same? Right? In the first example, we saw the domains were different, right? The original problem had a domain restriction. The final answer that after we did our long division, had no domain restrictions. But what about the domains for these two right here? Will they be the same? Same is right. Exactly right. Because both of them still contain the denominator of x squared plus 4x minus 6. So if this gives us some domain restrictions, well, we still have that denominator here. Even though it's not here, it's part of the original, it's part of the, the whole thing. If this is undefined, the whole thing is. So again, we still have that there as a potential domain restriction. So yeah. Okay. It's possible. All right. Questions on any of that? Oh, yes. Julie.
So for the previous one that we had a remainder on, that was the x minus 3. We still have the
Domain restriction.
yes, but do we have to write that one out? Because the last one has the x minus 3.
So I mean, so we could write again. I think you can feel free to put like the x cubed plus 3x squared minus 1x minus 5 plus negative 11 over x minus 3. But it's not necessary to put the comma x not equal to 3 because they both share still the domain restriction of the 3. So you don't need to worry about that. Yep. Okay. Any other questions? Well, I know as fun as this might be, right, we had to come up with some shortcuts because it's just, sometimes we don't want to take so much time to do these problems, all right? And that's where we bring in synthetic division, okay? Synthetic division kind of like takes away some of the, I don't know, some of the complication of the long division and stuff like that. Okay, so let's look at synthetic division. Okay. So, synthetic division, I like to describe this as a shortcut for dividing polynomials by binomials. Okay. A shortcut for dividing polynomials by binomials. Okay. Notice, oh, and I should say binomials of the form ax plus b. Okay. So, synthetic division, we sacrifice the ability to divide by anything, right? We can only do synthetic division with binomials, or dividing by binomials, but we sacrifice that ability to then be able to speed up our actual division here and stuff. Okay, so let me show you what I mean by that. So let's say our directions are something like simplify f of x, which is equal to 6x cubed minus 19x squared plus 16x minus 4 all over x minus 2. Okay. So here's our scenario, right? We're dividing by x minus 2. It is a binomial that's in the form ax plus b, right? A would be 1, b would be negative 2. Okay, so that's what we're going to do. All right. So what we're going to put in here, okay, this is the, like, I guess I want to say like the zero of the binomial. Okay, the zero of the binomial. That means it's not negative 2 we put in here. It's like x minus 2. If you set that equal to 0, what x value would give you, would make it true? It's 2, right? So 2 is like the 0 of this. It's like it is what makes this 0. So we're going to put a 2 in here. Okay. And then across the top, we're going to put the coefficients, right, of the polynomial we are dividing. Okay. Polynomial, the coefficients of the polynomial. Okay. Include placeholders. Okay, so in other words, if you jump from x cubed to x, make sure you put a 0x squared in there, right? If there's no x squared term, put a 0 in there for it. Okay. We're going to leave a line to do some work. Leave some space there. And there's our setup for the synthetic division. Okay. And we start by bringing the 6 down, the lead coefficient. Okay. And you take that 6, you multiply it with the 2, okay, which then makes 12. All right. And then you take the negative 19 and you add it with the 12. And then you repeat the process. So you can think of like the 6 being added with a 0, the unknown number here, so 6 and 0, that makes 6. 6 times 2, 12. Negative 19 plus, then you add these, so negative 19 plus 12 is negative 7. And then you multiply again. Negative 7 times 2, negative 14. 6 and negative 14, 2. 2 times 2, 4. Negative 4 plus 4, 0. Okay. This number at the end here, this is your remainder. Okay, so the remainder here is 0. That means this divided evenly, right? And these numbers here, these are the coefficients of your solution, but you must reduce the degree by 1. Okay? So in other words, we started with a cubic, right? Our solution is going to be quadratic, right? And so our final answer here then we can say is 6x squared minus 7x plus 2. Okay? And technically, I could write x not equal to 2, right? So I could say these two things are equal as long as x is not equal to 2. Because again, the domains would be different. All right. So is x minus 2 a factor of this polynomial? Is x minus 2 a factor of this polynomial? Yes. Why? How do we know? So yeah, Julie?
It's a remainder of 0.
Remainder of 0, right? When we divide them, there's a remainder of 0, right? So another way you can think about this is this polynomial, 6x cubed minus 19x squared plus 16x minus 4, it factors to be x minus 2 times 6x squared minus 7x plus 2, right? So you can that's another way we're using this to factor, okay? That's the way we're using this to factor here. All right. So let's do another one here. I'll do this one much quicker because, we've kind of now gone through all the craziness there. X to the fourth minus 10x squared minus 2x plus 4 divided by x plus 3. Okay. It's similar to the one we just did for the other example. So, what number goes in the box? -3, right? Again, for here we had x minus 2. The 0 of that factor is 2. So here the 0 of this is -3, right? It's what makes that factor 0. It's a -3. And then all of our coefficients. So my first coefficient is a 1, and then I'll put a 0. Ooh, very good. I can't trick you guys. And the next one will be -10, and then -2, and then 4. Or maybe someone was thinking the next one was going to be -10. They're like, whew, didn't say it out loud. Didn't happen if I didn't say it out loud. All right, so there it is. Okay. Drop the 1 down, right, and then we'll just go through. So 1 times -3, -3. 0 plus -3, -3. -3 times -3, 9. 9 and -10, -1. -3 and -1. 3, 1. 1 times -3, -3. And we're left with a remainder. Okay. And so then we'll interpret our answer here. This is equal to, we start with an x to the fourth, and so this will then be 1x cubed minus 3x squared minus 1x plus 1, and then plus 1 over x plus 3. Okay? Just like that. And on down. I'm going to give you guys one to try here. Finally, okay? And then I'll get you guys started on your assignment, okay? Okay. So before we get started on this, I just want to pause real quick and ask you some questions, right? Okay. With the way this is written, how can we divide this? Yeah, Julie? Long division. Okay. Why do we have to use long division here?
It's not x or ax plus b.
Right. It's not a binomial, right? Okay. Is there a way that we could divide this using synthetic division now? Okay, so yes, how? So the bottom factors here, okay? So Julia's right? With the way it's written, we seemingly would have to use long division here. You're right, okay? But Sydney, what did it factor to be? Okay, very good. Well, but still, Sydney, we can't do, I mean, how do you, I mean, synthetic division, we just got to do one binomial. So, I mean, how would you still use your synthetic division here to divide this then? Yeah, so basically right, exactly right. You're going to just synthetically divide twice. Doesn't matter which one you start with, okay? So Sydney said the -3 first, so you do the -3 with that. Then you take your answer for that synthetic division and divide further using the 2. And that would divide both. That would then divide by both of these, right? So synthetically divide by one of them, and then take that answer that you get and synthetically divide again by the other one. And then at the end, you will have your final answer. Okay? So Julie was right. If you see a problem like this, you're going to need to long divide, unless you can factor that denominator, in which case then you can synthetically divide. So you can choose whichever method you want there. I will be synthetically dividing. Oh, that's where I made my mistake. Mr. Wade. All right. Yeah. Oh, we're making it right here. Okay, so that's good. 2, 7, -4, -6, 1 times -3. Isn't that great when just that one little mistake and it was really early on, so you can change everything after that? It's really encouraging when that happens. Yeah. Say again, sorry? So then this final answer.
Yeah, I think
Oh, I see. So, sorry. What I was trying to say was take your answer for this, synthetically divide this by. Because dividing by 2 and then dividing by 3 is the same thing as dividing by 6. Oh, that's from the answer. Exactly. And that'll allow you to then further divide, right? That's what I was saying. Did it work out okay?
Does it matter which one
You do first? No. But I see what you did there. Okay. Oh, you're getting it to not work out though, are you? Let's see here then. So Just make sure you get this right. 2, 7, negative 1, negative 7, negative 18. Good. Negative 3 there. Good. 6, 1, 3, negative 7, 21, 6, 18. Okay, so that's good. So you took those numbers. Okay. Positive, good. Drop the 2 down. 2 times 2, 4. 1 plus 4.
Oh, it's plus.
Yep, remember you're adding as you go. Yeah. Yes. All right, so synthetic division, you actually can like line up your answer and do it all over again, right? So what I mean by that is I set up my original synthetic division, got my answer here, and since I was going to divide further, I just drew another box in there next to my answer and then did my synthetic division again. So you can kind of like just, continue off of that if you want to. If you want to do 2 separate ones, that's your choice, but you can just do it like that, okay? What the result here indicates, right? We started with a 4th power. The answer for that when we synthetically divided was a cubic. And then when we synthetically divided the cubic, we got a quadratic. So then we're left with what we started with, right? That equals x plus 3 times x minus 2 times 2x squared plus 5x plus 3, right? And so again, these can cancel out if you wanted to there. And so we'd be left with just 2x squared plus 5x plus 3. But did anyone notice anything about our final answer here? Yeah. Well, we have to limit the domain. Yep. So x would not equal what? Negative 3 and 2, right? But this factors, doesn't it? Factors, doesn't it? So what does it factor to be? 2x plus 3 and x plus 1. So in other words, we have the complete factorization of this polynomial, right? This polynomial here factors to be x plus 3 times x minus 2 times 2x plus 3 times x plus 1. These 4 binomials multiply back together to give you this original polynomial there. Okay? A polynomial that we wouldn't be able to factor by grouping. There's no GCF we can take out. We can't make it look like a quadratic using substitution or anything. Yet, we are able to factor it completely into 4 binomials and still solve it. If it were like equal to 0, for example, we could still find solutions using the zero product property. Okay? So, this is kind of how we're going to utilize synthetic division and potentially long division too to help us kind of like factor these polynomials and again still be able to solve them and things too. All right? What's the problem though with this method? What's that? Only works with binomials, right? Exactly. And we were given these binomials too, right? Like in GCF, in factor by grouping, in quadratic, using the quadratic and stuff like that. Those we weren't told what the factors. We didn't need to be told what the factors were. We just kind of do those things, and the factors just kind of show up. Whereas here, right, we're given stuff ahead of time, and hopefully it'll work for us. But if we're just told to try and factor this thing, you're going to spend an awful long time trying to guess what factors and what might factor and what might not factor, right? You have an infinite number of possibilities that this could, divide by. We're told some already to help us out, right? Once we get down to the quadratic, it wasn't a problem, but up to that point, we had to be given what to divide by. Monday, we'll look at the rational roots test, which will at least limit those infinite possibilities to a smaller number than infinity, but still maybe too large for some of your liking. But anyway, that's the best we can do sometimes. Okay, so. In the meantime, though, for right now, we're just going to focus on making sure we can long divide and synthetically divide accurately. All right? So your homework is posted on Google Classroom, so you can go ahead and check that out. Okay, I'd like you to go ahead and do that. If you didn't do the 10 marks that I assigned yesterday, you could also work on that. All right, but one of those 2 things I'd like to see you working on, so let's do it to it here, okay?